All right, looks like we're just a little bit past the top of the hour, so being mindful to everybody's time, we are going to go ahead and get started for the day. So hello and welcome. My name is Jerry Beeney, and I'm the Director of Global Business Development for the Research and Automation Cameras at Teledyne Flir. And I'll be hosting today's webinar. So whether you're here to kind of solve seal integrity issues, or maybe looking to optimize your inspection process, or maybe simply want to learn, more about the latest in thermal imaging, you've kind of come to the right place. Today we're going to be diving into thermal seal inspections, and specifically on bottle caps, with some insights into some of the different thermal camera options, as well as some of the ways you can integrate them into high-speed production lines. And then we'll also give some real-world examples of some customers who have implemented these systems into their processes. So joining me today is Eric Hughes, the sales manager for moviTHERM. Eric has worked really hands-on with numerous manufacturers to implement a number of advanced inspection systems. And today he's actually here with us to kind of walk us through what works in these systems, as well as kind of what doesn't work in the real world. So before we begin, I do want to go through just a bit of housekeeping. As you're probably aware, everyone's going to be muted, throughout this webinar. So if you do have any questions at any point during the session, there's a question and answer pane within the GoToWebinar interface. So just simply enter in your questions into there, and we do plan to allocate some time at the end of the session to answer any attendee questions that do happen to come in. So, and then secondly, if we don't happen to get to your question in the limited time that we do have, kind of before we wrap everything up with the webinar, we're going to make sure to follow up with you directly, over the coming days to answer those questions and help you out. So we're going to go ahead and get started. Eric and I are actually going to go ahead and shut off our webcam, so you don't have to look at our faces the entire time. You can focus on exactly what Eric is talking about, but we'll do that. But hey, Eric, how you doing today?
Hey, great. It's great to be here, Jerry. And it's a real fun topic today, so I'm looking forward to discussing some bottle cap sealing inspection systems for folks.
Okay, wonderful. So I guess first, as we get started, really want to talk about maybe some of the different problems people might have, with sealing issues. I think to a lot of people might seem small, but they can obviously cause some pretty big problems, within the real world. So I guess from your perspective, Eric, what are some of the most common types of seal failures that you actually see out in the field?
Yeah, we'll definitely get into that. It's I would say some of the reason why it matters so much to do this. These are really hidden problems, and I would say why it matters and why it's important, of course, is folks out there want to ensure product quality. They really want to reduce waste with a sealing inspection. You're going to be able to enhance safety and compliance with a system like this, minimize downtime as well when you do have issues. Some of the other things are boost your brand image with high quality product that you're shipping, and it really this type of system saves time and labor with kind of manual inspection type of systems, like pulling bottles off and manually inspecting them. You'll have traceability and documentation with this, and the one of the biggest ones is it eliminates recall. So there's lots of reasons why it matters to have an inspection system. And again, getting to your specific question in terms of what type of issues we can see. We've got this image on here, but yeah, overheating and underheating are big ones. So you want to really have a consistent seal. So and the thermal camera is just incredible for this type of stuff. But we're going to be able to see missing liners, product in the seal, which really isn't listed here, is a potential with this, misalignment on the caps, torquing issues that we're going to be able to see with the thermal inspection system. So there's quite a few that we can, find.
Okay, yeah, and that's great. Obviously, I'm just kind of curious, like how do some of these failures, typically show up in an actual like production environment?
Well, they're gonna, show up. The thermal image is essentially a thermal signature, and that thermal signature is going to alter when we see issues. So, how these failures happen, they can be, just simple stuff with just a misalignment of the cap, or maybe there's worn or damaged components. Even the sealing coil on your induction sealer may have an issue. Inconsistent line speeds. Maybe you have a defective liner in the cap. It could be from improper torquing on the torquer. That could really change the thermal signature by that pressure change. You also have the overheating, underheating issues, or maybe the bottles when they're coming down the conveyor are slightly misaligned, which can create a defect. Incompatible caps or bottle materials from different molds can have an effect, or maybe it's just human error that they put the wrong setting in. So there's just so many different ways that you can get these failures, and sometimes they kind of pop out of nowhere. Other times, you can start to see a trend. So, having a system that's doing 100% inspection on every single bottle can really ease your peace of mind.
Yeah, and there seems like there's a lot of variables and a lot of variability in the production process that need to be refined a little bit to make sure that there's actually really good quality seals happening. I think we'll get into that in some future slides, but I'm curious if you can kind of share maybe a real world example where maybe a faulty seal caused a quality issue or maybe even a recall.
Yeah, well, we've seen a lot with, I would say some of the biggest ones were with torquers. I would say that's a big problem. When you're getting issues with torquing, it's gonna show up on the thermal signature. Remember, when we're looking at this, there's really three factors. There's time, pressure, and temperature are the three factors that are creating the seal. So when pressure changes, with that different sort of torquing, then that's a major one. So with those type of problems, you're going to be able to pick those up, really quickly with this type of system. So I would say that one is probably the most common that I've seen, but we've also caught differences with people get, a lot of times they have different suppliers for the caps, and the caps from the molds aren't completely identical. So we had another situation where they were getting failures kicked off, and they couldn't figure out what was going on, and it was just because they didn't have the right settings, because the mold was slightly different on the cap. So in that case, we had a different recipe for the different molds, but that's how kind of gives you an idea how sensitive the system is. And they were just like cranking out systems that were not sealed properly at all. They had no idea.
Okay. Yeah, we definitely want to try to prevent that. So thank you, Eric, for kind of giving us a pretty good overview of some of the different challenges, that obviously like bottle sealing, can have. So I guess we'll kind of shift gears now and we'll talk a little bit more about maybe how thermal imaging can help solve, some of the customers' issues. So obviously thermal imaging, I think to some people, might sound a little high tech, but I think more people are familiar with it. It's really actually kind of quickly becoming a standard technology that's being used in a variety of different inspection systems. So maybe if we can, break down a little bit of why it's being used, and specifically what makes thermal imaging kind of an effective tool for seal inspections?
Yeah, it really has. The cameras, they're just getting better, more sensitive, faster, less expensive. And, people are aware of thermal cameras are, pretty much everywhere in our lives nowadays. But it's really kind of surprising how people really don't know that you can use a thermal imaging system to do this type of quality inspection. Even though this is a thermal process, so there's really nothing better that's going to beat the results that you're going to get from a thermal imaging camera. So first off, it's a non-contact measurement, and we can do it in real time, and we can do it at very high speeds, and so that's such a key factor here. And again, the cameras are just so sensitive nowadays, and they're accurate and they're repeatable. And not only that, they're affordable, and they're pretty small nowadays too.
Yeah.
So just is such a perfect fit for this application.
Yeah, and one of the things I think people hear a lot about when you're talking about like thermal cameras is kind of, they hear these terms like cooled versus like uncooled cameras. Can you talk maybe a little bit about that and, the differences and things?
Yeah. So, the cooled cameras, were the original ones, right? They used liquid nitrogen to cool down the detector. And so that's why they call them cooled cameras, because, when they originally were building these cameras, you needed to have the detector. If you think of like a regular camera, like a CMOS detector, that's what we're talking about, the focal plane array. That needed to be cooled down in order for the photons from the infrared spectrum to hit the detector. Back in probably about 1997, Flir first introduced a camera that did not require cooling. So a little bit different. The IR radiation that's hitting the detector actually, created some heat on the focal plane array, and they had a voltage that was being applied through each one of the pixels. As that heated up, it created a voltage change. And so it was a totally different type of technology. The result was the same in terms of the thermal image being produced, but we didn't need a cooler in this case. So they called those uncooled cameras. And yeah, there's definitely some differences between the uncooled and the cooled. And we'll talk about this, why a cooled camera would be advantageous in some applications. But I would say for the most part, maybe 90% of the applications, you can get away with an uncooled camera.
Okay. Yeah, and it seems like, a pretty good, understanding of that, and like kind of, I guess, describing like, with those two different, detector technologies that you
Mhm.
outlined, maybe a little bit of like when someone might actually need a cooled camera versus uncooled camera, or when
Yeah.
an uncooled camera might be sufficient for their application.
Yeah, absolutely. So you can see the image on the left, the video, and what they're trying to display here. When he waves his hand in front of the cap or behind the cap, you can't see the hand, right? So with the uncooled camera, it's completely opaque, and this is fine for most applications. When you have the cap torqued on to the bottle, it goes through the electromagnetic field and heats the foil up, and that heat is going to conduct to the top of the cap. So with an uncooled camera, we're going to look at just the surface temperature of the cap, but we do need some time for that heat to conduct to the cap. So, typically we would image this with an uncooled camera, maybe 2 or 3 feet from the induction sealer. Now, there are cap configurations that are challenging. So child resistant caps, dispensing caps, flip top caps with an extra layer of plastic. With CRC caps, they have an air gap, and that essentially stops the flow of heat to the top of the cap. So in situations where customers have these type of cap configurations, we go with a mid-wave camera. And again, mid-wave and cooled are somewhat synonymous. So we can, if you look in the video on the right now, and when the person puts the finger behind the cap, you can actually see the finger now. So at this wavelength, we're able to transmit through the cap and look right down on the seal. So there's some benefits there. We're able to still inspect the seal integrity with CRC caps. And the other thing is we can also, if space is a constraint, we can now do the inspection right after the bottle and cap come out of the induction sealer. So that's one of the main reasons why people would use a cooled camera for this type of application.
Yeah, and I think these videos really kind of highlight some of the different, the features of kind of the two different detector technology. So once someone kind of identifies, the use of maybe a thermal imaging camera, for this type of application, and they want to put it in their production, line, do you actually have any tips for like, how they have to position or where they need to actually position the camera on the line to get the best results?
Yeah, there's not a ton to this, but with an uncooled camera, as I mentioned before, we do need some time for that heat to conduct to the top of the cap. So you can't take the image too early. You can't take it too late when the heat starts to diffuse. So when we do this evaluation, we let the customer know, exactly where to position it. Now there's some flexibility there within 6 to 10 inches or so, but we'll identify exactly where you need to mount the uncooled camera. With the cooled camera, not as important. We can pretty much have that mounted right over the cap immediately after it comes through the induction sealer. We want to fill the field of view as much as we can with the cap. So you could see in the video, you want to have some Z-axis control for different heights of the bottle. So a lot of times we'll move the camera up and down in case of different heights, because we do want to have that cap fill the field of view as much as we can. And essentially, those are about the only tips. You might have some environmental conditions where you need washdown duty, stainless steel, things of that nature, but we have options for that. And I think the uncooled microbolometers are already IP, I think 63 rated or so.
Okay, yeah. Great. Yeah, so that's actually a really good kind of breakdown of exactly, what people need to consider, I think, when they're actually looking at, selecting the most appropriate thermal camera, and kind of how to, where they need to position everything to, get it set up to get some good results. So
yeah, and it's basically like completely vertically mounted right over the top. So that's one of the key things here. You don't want to do it in an angle, so you do want to have that perpendicular to the cap.
Okay, great. Okay, so I guess we'll kind of shift gears here, and we'll start looking a little bit more about like how quickly you can actually make inspections. Obviously, most product isn't just sitting on the line; it's moving at some relatively decent speeds down to the production line.
Yeah.
So obviously, people don't want to stop the product for their inspections, and any kind of inspections or different measurements that are needed. Really, the technology that you use really needs to kind of keep up with those line speeds as much as possible. So can we talk about kind of how these different thermal camera systems kind of work in real time, maybe on like those fast moving lines?
Yeah, definitely, because that's a big question when we first discuss this application with a customer. Speed always is one of the top questions that we ask, along with what type of cap configuration you have. So really, there's several advantages to the cooled camera. We talked about a little bit about the transmissivity at that wavelength. You also have the thermal sensitivity is much greater on those cameras, but the key factor here is that the camera has incredibly fast integration times, or you can think of it almost as exposure time. So the camera is 30 frames a second, but the key factor here is that we're taking the picture in less than a millisecond with these cameras. So, you know, these cameras can catch a bullet in air, and it looks like it's just floating. So it's not going to have any issue with a bottle cap, regardless of the speed you're running. You're not going to be able to, you know, outrun this camera. It's going to be very fast in terms of the acquisition. So with the uncooled cameras, they have something called time constants, and the time constant with uncooled microbolometers are typically in, you know, let's say the 6 to 8, maybe 10 millisecond range. So as the bottle cap goes by the uncooled camera, if it's running anything, you know, really higher than 70 linear feet a minute on the conveyor, we're going to start to encounter blurriness. So, you know, that's the key factor here. So if it's over 70 feet a minute, even if you have a standard cap, we're really going to be forced to go to a cooled camera, the A6301.
Okay. Yeah, and I guess that's a pretty good like demarcation mark, because I think a lot of people ask, how fast can I run, you know, my line before I maybe have to move to a different camera technology. So yeah, that's at 70 feet a minute. It's probably, you know, yeah, that's useful information, I think, for most people when they look at their production line. So obviously, like in this image, you see the bottles passing under the infrared camera. Is there any way to, you know, you can kind of synchronize when that image is actually being taken so that you're fully on the individual bottle cap or a group of bottle caps, and you don't have some, you know, aliasing errors where you might catch part of one cap and part of another?
No, we don't really get that. And you can see the photoelectric sensor in the screen here. And then we also, you know, looking at the caps too. But yeah, the proximity sensor is going to trigger and send a signal to the camera on when to grab the image. So we're going to have very precise synchronization and control, especially with the cooled camera. So it's going to be waiting for that signal. We send it a trigger from the proximity sensor, and that's going to grab the image, and that circular cap is going to be right in the center of the image every time. So it's very precise in that regard.
Yeah, and I guess it feeds into just the repeatability and the ability to make those measurements, you know, from cap to cap to cap, which is vitally important. So I guess, you know, as this system is running and it's looking at all these, you know, different caps, like what actually happens when a defect is detected? Is there some way to basically, like, you know, do a reject process automatically?
Yeah, so we have a computer that's running our application, and when we get a failure, the PC process is maybe 75 milliseconds or so for us to, you know, take a look at the image, process it, and figure out if it's a pass or a failure. Once we find out that it's a failure, we can do a number of things. One is we have digital I/O that we can send an output to, so we can send it directly to a rejector. And a lot of the times that's time-based. So if you have a conveyor that's running at a consistent speed, you know, you may be able to just say, okay, let's reject it in a half second later, and it will send a signal to the rejector and it will reject it. In other situations, you may have a PLC that's already on your line that's tracking and doing the reject. And in that case, a lot of the times we can just go Ethernet IP or Modbus TCP and connect our computer to the PLC, and then the PLC will run the logic to kick it out. In the video that you're watching right now, we have yet another method, and that's if you don't have a PLC and you want to be able to track the bottle, we put an encoder on the conveyor, and we put a small micro PLC in our enclosure. And now we track a physical distance. And once we get to that distance, we can go ahead and fire a signal to the rejector to kick it out. So, and then you even have light tower. I think we'll have a light tower picture down the road, but in some basic applications, we can just have a light tower, and an audible alarm, give an indication for something to grab the ball.
Yeah, so it seems like a pretty complete system. So, I mean, obviously, speed and having the technology and the camera and the analytics to kind of keep up with the speed of the line is obviously important. But I'm sure kind of, having some level of consistency in the manufacturing and the overall inspection process is probably just as important, if not more. So, because personally, I would think maybe small changes, upstream in the line could actually lead to some pretty unpredictable defects. So I guess, Eric, if you don't mind, let's kind of switch gears a little bit and start talking about some of the process variability aspect as well in seal inspections. Because I mean, yes, because obviously, a lot of people listening probably understand, that, many manufacturers have to deal with, kind of inconsistencies. And as you mentioned earlier, seal pressures, torques, changing temperatures, and sometimes, I think even in your example, about the variability of materials, which, I mean, as you said, can all lead to defects. So I guess, Eric, how do you think, kind of that process variability, like all those things kind of can affect the inspection reliability?
Oh, and yeah, it's a huge, it's a huge issue. And when people get these inspection systems, they're mainly like, we want to, kick off defects. But, the first thing that we do is, the system is going to give you an incredible amount of data on your sealing process. So it's going to be able to give you that sort of feedback to see what type of process variation you're dealing with this system. And the wider the process variation, and this is a kind of a good kind of visual on this, and you can see an ideal kind of curve here, and we're looking at bell curves now. And when we look at process variation, they come across as a bell curve, right? You take 1,000 bottles, not every single one of them is going to have, a peak temperature of 100 degrees. You're going to get some variability there. So, that's what the bell curve is trying to display. When you get failures, you want to have the failures reside outside your process variability. So, at 102, we want to be able to kick that out. So, or even a 98, so if it's beyond the process variation, we're going to be able to, find that defect and kick that out. And you can see, it's even useful if you get a little bit of, carryover with the failures inside the process variation. But the last thing we want is having a really wide process variation. And it's just the failures, the defects are just going to get caught up in the noise of your process variation. So that's one of the key things is when we set the system up, you start looking at hundreds, thousands of bottles, you're going to get a good idea of the process variation. A lot of times you can make adjustments to maybe the torquer or the capper, or maybe it's the line speed. So there's just so many variables that you can really tighten up and get that bell curve as sharp as you can get that.
Yeah, that's great, because obviously, just consistency of measurements, key, and kind of tightening up the variability is important. So I guess, kind of given all that, with the thermal, inspection systems and the sealing, are you able to, kind of detect all those like upstream process issues maybe before they can even cause a defect?
Oh yeah, I mean, especially because if we're getting tight process variability, and we're starting to see maybe issues with the filler, maybe there's some product around the seal, or potentially torquing issues. those are going to just really stand out, and we're going to be able to capture those along with maybe even capping issues, and even with your induction sealer, we can potentially find issues with that before it gets to the point where you're creating bad seals, because we actually have a warning system as well. So we have warning alarms in addition to red lines on failure. So you'll be able to get some warnings and get some insight into what's going on before we actually get a failed seal on there.
Yeah.
So that's where we have that warning level on.
Yeah, and that's really valuable, because I mean, ultimately, it's good to catch, sealing issues, but if you can kind of almost predictively determine what's happening upstream, you're going to improve or reduce the amount of, failures that make it through, or a lot of times it can also reduce some of the scrapping. The cost of scrapping multiple things. So I guess when you talk about some of those warnings and everything, are the operators, who actually use this system, for kind of, can they use it for like that process tuning and not just for those like, rejecting defective, products?
Oh yeah, you definitely. I mean, you could change the torquer, and you're going to be able to, immediately see what type of impact that has on the temperature data, right? So we're not looking at pattern recognition here. We're actually looking at quantifiable temperature data from the IR image. I mean, when you grab an image, we have temperature at every pixel, down to 100th of a degree. So these cameras are very repeatable, and anything that starts to get outside the lines, we're going to be able to catch with these. And again, the tighter the process variation and the feedback we give you this allows the customers to really tighten the process variation up, and in turn, you're going to be able to see really, really small defects and changes.
Yeah, that's really interesting. And obviously, when you have an operator on the line, if they start seeing a potential defect that might, something upstream of it, they probably have to, provide some level of information to other people on the production floor. So what type of like reporting or like different alerts are available, out of the system?
Yeah, well, you'll get the warning signature on the software. We have the light tower that it will give you an audible alert when there's, you're starting to creep into the failure mode. Obviously, when you get a failure, it's going to reject the bottle. So you'll get the reject, and then you can go ahead and test it, but and inspect it. But you're gonna see warnings, and the software's gonna tell you exactly, on a certain run, how many went into the warning level, how many were failed, how many were good, and then it stores every single one of the images. So and again, as I mentioned before, every image has hundreds of thousands of temperature points on there. So we can go back and do an analysis on the images that have been taken. So there's all sorts of ways to go back and look at this, and to view what's happening real time on there. And these are used in the pharmaceutical industry. So we're method 21 part 11 compliant, that allows every user, when they type in or they change a parameter, change a recipe, all that is logged in addition to all the data that's captured.
Okay. Yeah, and that's helpful to understand that, and kind of gain that better understanding of really kind of how this system, operates, how it can kind of help stabilize production, but then also like the outputs that it has, and just generally it's not just a single seal inspection, but it can actually help people like optimize a large part of their production process when it comes to bottling. So I guess we can move over to taking a closer look at what a properly sealed like bottle cap actually looks like. When you're using a thermal infrared camera a little bit, because I think as many people in this industry maybe already know, not all sealing defects are obvious at first glance, like you mentioned. So could you maybe tell us a little bit more about what the thermal camera is actually seeing or maybe actually measuring?
Yeah, and if you could go back just a couple slides, Jerry, I did want to mention one thing. Um, yeah, maybe before the video, because we'll watch the video here in a second. Yeah, so here's an example. The system is alarming on a statistical analysis. So when as I mentioned, you have warnings and you have the red lines. The yellow lines here are the warnings. If you look in the bell curves that we have, and once you run a bunch of bottles through here, we're going to get these bell curves. And the user has the ability. This is not, a system that's, where you have no ability to change parameters and alarm. We'll give the users the full capability to do that. So if you look at the highest peak one, you can see that the red bars there, and you can see there was a few that went outside the red line. Those would get rejected and kicked off. But you also have your yellow line, your warning level. So the end user can just simply drag those alarm parameters and set up their warning and alarms, based on the or the bell curves. And the bell curve is going to get tighter and more narrow the better our process variation is. If you go to the next video, you'll see how we build those bell curves. And I think they took 1,000 images, and you'll see the software just running through each one of these images. You could do this live, you can do this from stored images, and it's going to create those bell curves that we're looking at here. So, this is a real key aspect of how the software works.
Yeah.
We're going to take a bunch of samples. I'm sorry, go ahead.
No, I was going to say, it seems like very interesting, because if you can do this kind of in real time and you have like a, rejector, in the line, as you tighten up those parameters, you actually get to see kind of in real time exactly, how moving those parameters affects ultimately like the level of rejections or percentage of rejections, which I think is really valuable for people.
Yeah, no, it is. And this is, I think we talk about this later, but this is how we go ahead and set up the system, right? We'll go ahead and set it up. We'll start grabbing, hundreds, thousands of bottle caps, and then we'll go ahead and we'll create a recipe for this. And this is pretty much how it's done. It's kind of a glance into the recipe manager here.
Okay, great. And I think everybody can see in the top left there the actual thermal image of the seal. So I guess I'll move a couple slides ahead, and we can talk about kind of what are the key thermal indicators for an actually properly sealed cap.
Yeah, so you really want to have consistent temperatures across that that outer diameter seal area. I mean, that gives you a real good indication where we want consistency across there. And you can see it kind of flashing up, and you see what we call spokes that we'll draw the line from the center to the edge, and now it's grabbing the maximum temperature on the line. And not only well, they call them rakes here. I call them, they're interchangeable rakes or spokes. But you also want to make sure that they're symmetrical, and that from a geometry standpoint, that the hot spot on the line is at the same location. So there's a few algorithms that we run for that, but that's really what we want to see. We want to see real consistent temperatures right on that seal area, and the geometry of the seal area to be consistent in order to really look at a nice seal. And as you mentioned before, like even small variations, whether there be product in that seal, liquid, if it's slightly misaligned or mistorqued, you're going to be able to pick those up, quite easily, really.
Yeah, yeah, and I think people that are on this webinar might be familiar with thermal image, but typically it seems like you guys follow the parameters of like white hot, black cold, type situation. So obviously the brighter part in the color palette is a warmer section on those seals. So when you see something that's a little bit darker, or one of those kind of cold spots, like what could that mean ultimately?
Well, I mean, if you have a cold spot there, it could be a lot of the times either underheating. If you have any sort of, a lot of people, liquid on the seal can be a problem. That usually will show up as a bluer area. Sometimes if you see some of those seals have a little tab that kind of folds over, those act as like a little heat sink, the ones that you can kind of get with your finger to pull off the seal. Some of those little tabs act as heat sinks. So you might see something in seals as well, but typically it's areas that aren't bonded very well.
Okay. Yeah, and obviously, I mean, you mentioned previously that uniformity, thermal uniformity is really good, and kind of that consistency that you want to, have a good seal. But why is that specifically?
Well, you just really need to have, the repeatability there is going to be key to doing an inspection system. So you want the thermal consistency, but you also really need to have this be repeatable as well. So, and again, it kind of goes back a little bit to our process variation topic, but that's kind of the key factor with this is, anything that's going to impact that. Essentially, this is a thermal signature, a thermal fingerprint, and if we get any type of variation in the that's outside the norm, this is going to really impact the thermal signature, and the system's going to pick it up.
Okay. Yeah, and I guess when we look at some of these examples of what a bad seal actually looks like, I mean, I think you touched on a few of these with respect to the overheating. I think prior you talked about the loose caps, but I don't know if you want to talk about anything specific, in these images.
Yeah, I mean, the one on the left, sometimes it's hard because the IR camera will auto adjust. So, just looking at an IR image, you don't really know if that's overheated or not overheated. So we that's why it's so important to base our decisions on temperature data rather than just pattern recognition. So we're getting temperature data and basing our alarms on that. The loose cap and under torqued, always shows up as this kind of wavy on the edge, type of image, and you can kind of see those little hot spots or cold spots along the edge. That's like very notorious for an under torqued loose cap type of problem. The missing foil in there, you don't have, as it goes through the electromagnetic field, you have, no metal to even heat up. So that's going to be a real no-brainer. And then double seal, again, double seal is, it's going to lower the temperature that we see when it goes through the induction sealer. You're not going to get a proper seal. The temperature is going to drop, and we're going to be able to pick up that type of problem very easily.
Okay. Yeah, I mean, it seems like these inspection systems provide a lot of information, but I think in general, I think in most people's minds, they're really only useful if they can actually like get them to work like in their kind of real world production line. So, so why don't we go ahead and we can kind of shift gears a little bit again and talk about some of the logistics that customers have to consider when they actually want to implement one of the moviTHERM systems into their production.
Yeah, I mean, the first thing is we really like to get some samples sent to us. So we'll ask for, 20, 25 samples to be shipped to us. We just want to validate that, we're using the proper IR camera. Some people tell me they have CRC caps, so I'm automatically thinking I need a cooled camera, but then the air gap is so small that we actually can get away with an uncooled. So, we'll go ahead and take your samples, take your different configurations, we'll run them in our lab, and we'll create a report, and we call it a feasibility study, bottle cap feasibility study. So that's kind of our first step, is to do that. And then if it all looks good and the customer buys the system, we ship it out there, we'll send an engineer to go on site. What we require from the customer is that they mount the camera, put the enclosure on the wall, or in this case, you can see the floor stand here, and mount that. And then when we go out there, it's all powered up, and we'll go ahead and kind of what you saw before with those bottles going along in the software, we'll just run a bunch of bottles, and we'll create the recipe right there on site. And we train you how to do this. So when you guys, get new bottles, new different types of caps, new configurations, you have the capability of, doing this. Now we can remote into the software too, and look at what's going on, and actually help you out as well. So, that's another nice component of this. But yeah, we'll go ahead and get this all set up and working, and get you guys trained before we take off. And you can, again, the picture here is, a nice system because it's all on a floor stand. We can put those on casters too, and you can move that around from conveyor to conveyor and just plug it into the wall. And you can see the camera with the arm on there has some ability to do some XYZ motion.
Okay. Yeah, and obviously, I mean, Eric, it sounds like you have a lot of experience with this. So I'm just kind of curious if you have any, like, things that you've learned when you're out in the field that you maybe could recommend to someone that's actually considering using this technology for thermal seal inspection.
Oh, I think what what we probably see is that you're getting a lot of insight on your sealing process that you've never had before. That's really, it's going to open your eyes to, really allow you to see what's going on with the sealing process, which you never really knew about before. Typically people would just take, a bottle off the line, squeeze the bottle, put it underwater, do a bubble test or what have you. And, that's just not a real effective way to inspect these when there's something that's proven and it works and is really very easy to implement, right? So you don't even really have to stop the line, right, to set this up. So yeah, I would say that was kind of the biggest thing, is people are real surprised that the type of information they're getting back from their sealing process.
Yeah, and it seems like for most processes, it's flexible, but yet provides that, repeatability, so people can actually have confidence in the outputs that it's providing, versus if they do a bubble test or something like that, where it all kind of depends on the human doing it at the time, whether or not they deem it bad or not ultimately. So
yeah, and it's just hard. Sometimes you get these defects that just come out of the blue. We were doing another customer where they ran 10,000 bottles. They had maybe a handful, 35 out of 10,000. So it was not a huge number, but they had all sorts of different types of issues that our system was picking up. So, these are just random events. And, in some cases, I'd say most cases, people don't want to send out bottles and caps that they're unsure of. And so it really gives you a real good, I mentioned a bunch of stuff early in the presentation, but it really gives you peace of mind. And that's one of the key factors of a system like this.
Yeah, and I think one of the things is some people just don't know what they don't know. They kind of make assumptions that their process is doing certain things, and this can help kind of uncover, maybe what it isn't doing or doing poorly. So.
Oh yeah. That's what the listings with the thermal cameras, right? They allow you to see things that you can't see with a visible eye.
Yeah. Exactly. So, yeah. So this has been great, Eric. Yeah. So thank you for all the great information on using these thermal inspection systems to detect the seal defects. I personally feel it's been incredibly insightful and helpful. I know I actually learned a lot, and I hope the people attending the webinar today feel the same way. So with that, I mean, we have about 10 minutes left, so I do want to shift over and answer a few of the questions that did come in while we were talking.
Uh-huh.
So again, if you have not done so, and you do have a question, go ahead and access the question and answer panel in the GoToWebinar interface, and we'll see how many of these questions we can get through in the time we have left. So let me take a look at here at some of the different questions. And all right, yeah, let me ask you this one, Eric. Let's see, is this type of thermal inspection better suited for hot fill or cold fill bottling lines?
Yeah, that's a good question, Jerry, and I didn't mention that one before. So it is definitely better for cold fill, ambient filled. When we get hot filled, it's really the probably the Achilles heel of a thermal inspection system. Just the hot fill is going to heat up the bottle, it's going to heat up the cap, it's just going to flood the IR camera with too much heat for us to differentiate and do an inspection on the seal. We have some ideas on how to still inspect these. If so, don't get totally discouraged for any folks out there that have a hot fill application. It's going to take a little bit more effort, maybe a secondary induction sealer when it cools, but we have some ideas on how to do this. So, but yeah, that's a challenge with hot fill.
Okay. Yeah, it looks like someone also asked a question about, can this inspection system handle, some differences or variability in, like, if the caps have different colors or different shapes or slightly different materials?
Yeah. So colors don't matter too much. Shape, I would say, if you have a different type of configuration, maybe the air gap's different on these, maybe the thickness of the liner could be different. I mean, that's a big one where people don't think that makes a big difference, but it really can. So, in those cases, what we would do is create different recipes for those. So that would probably be the ultimate answer. If you have different types of slightly different cap configurations, we would just curate a different recipe, and recipes are unlimited.
Okay. Okay, great. And then it looks like someone asked, can this thermal inspection, work alongside other inspection systems like maybe visible cameras or X-ray, or is it more of a, or they say, or replacement? So I guess they're asking, like, is it more of a replacement for those methods, or what are your thoughts on that?
Yeah, it's not going to replace the X-ray. Sometimes we'll use the same rejector that the X-ray is using, as long as it's downstream from us. So, but it doesn't replace necessarily the X-ray. We could, if they have some other vision systems that are looking for crooked caps potentially, there may be options to eliminate those ones, because we do have some crooked cap options for sensing those. So, but yeah, I would say not the X-rays. We can utilize a lot of them, maybe the rejectors already, as long as they can handle a 24-volt DC output signal from us. Then we've done integration with other types of rejectors that are on X-rays, or maybe even weighing stations for other package sealing systems.
Okay. Oh, that's good to know. And let's see, we've got a couple more questions. Next one's, has this been used, for other things besides bottle caps, like maybe pouches or seals
Yeah.
for like medical packaging?
Yeah, definitely. I mean, really the same kind of theory applies, where we'll, instead of, as you saw those lines, what I call spokes, with seals, we call them rakes, but we just draw those lines perpendicular to the seal. And, we got hundreds or, potentially thousands of those lines where we run, again, our algorithms on. But yeah, absolutely, ultrasonic welding applications, package seal, all sorts of sealing that's, when you're sealing with thermal energy, then we can inspect it.
Great. Yeah, and thanks, Eric, for answering a lot of these questions that people have put into the questions panel there, and actually just kind of answering them on the fly. So I think it's been really insightful. And yeah, some of the questions that we had from people, I think were really good to help kind of clarify some of their understanding of this as well. So there are a couple more questions in the queue, but we're not going to answer them because I know that we only have about 5 minutes left, and I actually have a couple of wrap-up questions that I wanted to ask you before we close here in the next couple of minutes. So I guess the first one, Eric, is if someone is actually interested in kind of getting started with the thermal seal inspection system, what's kind of their first step?
Yeah, so the first step would you would just give me contact me. We'd probably do a Teams meeting to start with, and I'll just get some basic information from you. As I mentioned, we'd like to get some caps. We have a form, an online form that you'd fill out. We're going to replicate exactly what you're doing on your production line in our lab. So we create a report for you. We send you the report. We go over the report with the engineer who did the study. And then we're very confident that our system's going to work for you. And then it's a matter of quoting it. I'm sure people will have some ideas or questions about how much these systems cost. Typically, they're in the $42,000 to $47,000 range for uncooled systems, and around in the $90,000 range for the cooled camera systems.
Okay, great. And if someone maybe just wants to do a little bit more research themselves, do you have information on your website or somewhere where they can learn more about the systems?
Yeah, we've got some nice videos that show how these systems work, a little bit about the thermal cameras and the software. And so yeah, we do have some really nice videos if you go to our website that you can take a look at.
Okay, great. Yeah, it looks like we have the website up there on the last slide here. So yeah, I guess with just a couple minutes left, we'll go ahead and wrap things up for today. Did you have any closing comments, Eric?
No, it's just thank you, Flir, for giving us the opportunity to talk about this. When customers call me, they don't really have much insight into this or didn't realize that this technology works. So just being able to share this knowledge and to educate people out there on how effective this technology is for checking seal integrity is a great opportunity for us. So we appreciate that.
Oh, you're welcome, Eric. Yeah, and like I said, I think I learned a lot about it today. So hopefully everybody else that attended the webinar today learned as well. There are a few things that I didn't know, and actually kind of having you walk through the process and some of the pros and cons and some of your experiences, I think have been really valuable, I think, to everybody in attendance today. So I do want to thank you, Eric, obviously for sharing that expertise. And I actually want to thank everybody who actually tuned in today for their time. As I mentioned in the beginning, we're actually going to be sending out a replay link to this webinar over the next couple of days. So if you want to replay it or anything like that to look at, because we did go over some things rather quickly, you'll have access to that. And if you did want to talk to someone from the moviTHERM team, we're going to, in that follow-up from this webinar, we're going to go ahead and include their contact information in that email as well. So with that, we're going to wrap this up for today. I hope everybody has a great day, and we will see you next time. Take care.
Thank you. Bye-bye.
Bye, everyone.